Hello guys, Mr.Dragon here. And this tutorial I would like to show you how to speed up searches with gameguardian, specifically group searches, because it turns out that if you are doing group searches with gameguardian, it can take some time before the results are displayed in the result list. So it takes way more time than doing a search that only has like one value. Like let's say like this group search would take quite some time, because we also have all the regions open here. But if I would just do like, for example, 1080, then the search would go very fast. You know, the results would be displayed very fast. And now this is the example I will be using as a small game, but imagine if the game is quite big in size. You would like to avoid having those slow searches, those slow group searches in particular, um, because nobody really likes slow searches, you know. So you kind of like find some workaround, or like be a bit more efficient about it. When you are scripting it or when you are doing it manually, kind of comes down to the same thing. So yeah, this tutorial can take some time, because I also going to need to script a bit. So yeah, follow with me. Also, I maybe make a second tutorial about like pointer searches, like a bit more in depth, um, for like make better or like more efficient cheats with game guardian. So just so that you know, like if you see anything that you think is wrong explained or something, you can always correct me on that. Um, I only care about like I'm only interested in sharing a bit of my knowledge. Doesn't mean I'm a teacher of any kind. It's not like I went to school for this stuff. Um, but anyway, let's go with the tutorial. So I have this game. It's called Koromon. It's a perfect test example for the tutorial. So I want to, let's say like I want to modify the attack value. Now it's 11. Of course, I already knew the value, how to find it in this game, um, because I tried to cheat this game before on request of somebody on the Game Guardian forum. So I know that um, 11, like the value here, is actually 130 and double. So if I change this like to 99 something and like go back, you can see that the attack value changed. I have, so this is a Kodomon, or you can call it a Pokemon, but in this game it's called a Kodomon. I have two Kodomons, so I have one and two. Both are level 5. One is called Subject 0, other one is called Subject 1. As you can see, the attack value only works on Subject 0, but not on Subject 1. I don't like that. I want to have a value that, or I want to find a way in which the attacks value are modified for each Pokemon, as well. Because nobody likes to do group search by group search for each Pokemon, you know? So, okay, this is the value. So if I want to make a group search, I have here something. The problem is it's not efficient to make group search. It's almost not really, like, it's possible, but it's not efficient because look, like I have now 6 results, right? Um, I copied them in Word. I could do it in double as well. Yeah, let me do that. Let me copy that in double. Comes down to the same thing, but let's do that. So you copy a few values around it. See, now we store them in a save list, and I do copy. You add types and add the group size. Then voila, copy. Can remove this. Now let's search. There we go. And you press ordered. See, it's already taking like, I think that was like 2, 3. Yeah, it was like maybe 4 seconds or 5 seconds. And you can see I have way more results than I need to. I have more than 6 results, you know. And if we now refine 230, see I have 22 results. You don't want to deal with that, you know. You want to, you like, you want to be like a bit more, how I say, you have to keep in mind you have so many results, and this is just like with the objective of having this one attack value of this one Pokemon. You know, you don't even know if you have the other Pokemons, if you have the attack value of the other Pokemons. So um, then you also have to know, like, you get, for example, you go, for example, to subject zero, sorry, to subject one. There you have to try again, search for the attack value, because it's maybe not 130, it's something else. So it's a lot of drama you don't want to deal with, you know. So imagine you have 10 of those Coromons, you need to do 10 searches. Nah, at least me, I don't want to do that. So what we can do is we can use the pointers for the find, like a base address, you know, like a base address to which all the values of the attack, or at least the pointers that are relevant to the value of the attack, are pointing towards. So let's remove this. We can keep this one here. So let's remove this, and yeah, go to the address. So we won't script this group search. We're not gonna do that. We look for something else. So here we have a pointer. That's our first pointer. So we can already try that one out. So you can see it's on offset 10 here. Of course, I expect you to kind of know a bit the game. You're cheating. So we go to the pointer. We end up on the 0. So that means there's no pointer further. We have like 2 values here. We don't know if they are changing or not. We don't know that. Like for that, you have to restart the game. You need to restart the game, and if you can find the values again, they're not changing. So first we see what happens if we do pointer search. Remember, this is the address we jump to. So we do the pointer search, address, and then offset, new search. We get we get a lot of results. And now we do what we did before. We calculate the offset. So we go back, and we know that our offset or double offset is from pointer, like start, or let's say like, yeah, base. You can actually say start. Um, Start address till the end address, or like desired address was how much? It was 10. So that's our offset. So we save them. You can delete it, by the way. We save. I do like 10. You see 10. You do in hex, double. Okay, we see a lot of values. You see a lot of values, also values I have touched before. So that's a good sign. So it also means that other attack values, very likely those are all attack values of other Coromons, are involved. So we obviously know that an attack value is not going to be a minus number. It's going to be a positive one. So we need to filter that out. But me personally, I have a script that filters out like any value that has like more than one digit, and that is not like how to say, like, and that's not negative, and that's negative. Sorry. So I execute it. So yeah, here we have all the values, and if we like turn them all to 99. Okay. Okay. Now you can see that the attack of subject 1 and subject 0 are both on. So this means this is a good pointer. We can revert the values and remove them. So we already know that whatever is on the 0 here, Let's call this our base. Let's just call it base. Um, we know already that every pointer, like everything that's pointing to this address, as on offset 10 as attack value, as the attack value for every Pokemon. For every Pokemon. So now all we have to do is basically script it. So yeah, oh look, here you have a string. It's literally called attack. So this is kind of clear to me that the address to which all those values are pointing to um, also is like near the literally like the string name of like the feature, the stats we want to cheat. So I assume that that's the same for HP, speed, defense, SP dot defense. Maybe written a bit different, but the logic would be the same, no? Like first base pointer, like a base address. Sorry, let's say like base address, and then few offsets below we have a string name. So let's start with this value. Like first, we need to we need to see if we have a static value. We don't want to do group search, otherwise that would like defeat the whole point of like doing faster search. Um, so we can start like with copying this value. It seems kind of unique, so we can restart the game and see if we can find the value again. Let's just restart it by the through the value we just copied. So Coromon is starting. So okay, this is the value we just copied. It wasn't Word. So we search it and we have our result. So that's nice. We can use that. So you can always, I always advise you to run like a few tests, like restart the game a few times and see if the value is the same. But like for tutorial purposes, I'm not gonna do that, like because the value is gonna be the same. You see, you still see the string name, attack. So we already can start with doing well, we always start a script. We can search number. The Here we go. So yeah, here you always put the value, then the type, which was dwarfed. My English is not that great, so I won't be able to like say all the words to be honest. Okay, so we know what that's gonna do. I save it. I call the script com the trafsoft.coromon.lua. It's always good to call the script to like what's the package name. So like here you can always see the package name com the trafsoft.coromon. Yeah, everything behind doesn't matter. Uh, so then um, here was our zero, our base address. So oh, oh, definitely wrong. It was this one. So I see here we have our results again. So now we just calculate the offset from that value to the base address. That's C. So we have to do minus C. And observe how now this value is 4. Before it was something minus 6, like it was a big value. I know it suddenly changed. So that value was not reliable. But this one is reliable. And the offsets are the same. So yeah, offset was C. So first we do the GD search number. Always execute the script now and then. So trust.com. So we just executed the script. So working fine. So then yeah, so after it finds the value, look, the value changed again. See, that's why you always have to restart the game just to check it out. So yes, we do the current address. So let me show you. we can use, I know I get one result, but we can always use gg.getResults count. So like this, get results count. So basically what it does is it counts in a way of saying it counts the amount of results you get. You can see it like that. It counts the amount of results you get. So if you're a bit familiar with Lua scripting, a little bit like me, you can use the print count, and then it will like display like the behavior. So we execute again. And now it says how many results? We get one result. As you see, one result. So, okay, I hope. So now we need to store the result in a table. So results equal. So we need to use get results. You can use the Lua documentation on the gameguardian forum with like full explanation of each function or command available. So count. So now if we print results, we have to print it. We always have to check what's in the table. So the table is referenced to a variable named results. So let's see. See, that's our table. Here we have our table. So the table exists out of the following, like it's a table and it has one subtable. So yeah, that's the one you saw in the previous print. So the subtable exists out of address, out of the keys address, flags, and value. As you see, here is our value. This is the flag, which is dwarfed, as you can see here, dwarfed. And this is the address, which also will be able to see here behind. This address is the same as this address. So now what we do is, so we have to like, since we have one result, I mean, we can just do like this basically. So results, and then one dot address equals results one dot address, and it was minus C. So it's hex, so you do like this. You can use caps. So what happened now is, so if we go to this address, so like I told you, we had to do minus C because this is our address. So basically we do this calculation, this address calculation here, minus C. So in hexadecimal, we will end up to this value, this address here. So every print, let's print both here and let's print here. Say like offset. Let's execute the script again. So here you can see the calculation that has been done. So this is the original address, like after we found the value. And this is the address when we did minus C. You can see the difference. It's now minus C. So on that address, we have all those like all the pointers are pointing to this address. So we are basically now here. Now we are here. From here, we go to here. So now what we can do is we can now search this address. Like basically doing this. So pointer search is basically would be the same as searching this address. the green one here. And since we are now working here, we can just do like this. The search number, and then result one dot address. And then because I'm on 64-bit, my address is like minimum like longer than 4 bytes. So you have to use quart. So type quart. Voila. So let's see what we get. We also have to not forget to clear our results first. So here we can put clear results. So this will clear the result list. There we go. So let's remove. Let's see how we get it now. Oh, there's a little fault here. You have to use cap. Seems alright. You always like to prefer that you always like to check it. Okay, let's do the search. Voila. You see now it's already done. So the script first searched this value, then it jumps to this address basically, and then it searches all the addresses that hold this address, the green one, as a value. So equals pointer. So we are already correct. So all these values or pointers are pointing to this address. So now what we have to do is, remember, we have to do the offset plus 10. So example, random example, but we do here. So this is the current address now. Those are the current addresses. I do plus 10. So let me check. Oh, man. It's on 8. Funny. So here we have the 10. So 10 in decimal. Okay. So now we have to script that. So basically all we have to do is, since we have a lot of results, first we store in a table results equals, let's see, good result. We can basically just call it attack. Good result. And also you have to do count. We can again use this. So voila. So now it's stored in the, now we have our table and we reference by using the variable name attack. So now we can do this. That will be appears attack do. And so now we can say that each address, so all the addresses in the result list, all the addresses have to jump like 10 hacks. So address equals address plus next 10. We set the flags because the value was double. Remember, like, or all the values are actually double because here it was 130. So what we do is we set p.flags equals type double, and then end. And then all we have to do is is get the values. So actually we can, yeah, just like this. Tag equals get values. So that will give us all the values. Like it will get the values from the current subtables, like from the current addresses. So like attack, here we go, and then we can use. Oh, we don't even need to do that. We can just do load results, attack. Here we go. Let's print now. So let's do execute the script again. Let's always see if everything is like, if there are no mistakes. Currently, I don't see a mistake right from the bat. So let's execute. Voila. So now we have all our double values again. Remember, as like in the start, we have all of it. So if I now execute that one script again, this string the formatting, Lua, and like change to 999 or tag value. So this whole process went faster than doing like the whole group search, like one group search that was just working for one Pokemon. But now we have like a small script that finds us all the values, and you just edit them to 9999. You got like in the same amount of time as the group search, or even faster actually. And all the Pokemons have like big attack value, and it was for all. It was like how say like it was faster than the group search, so that's good. We can revert. So what we can do is actually you can make this script a little bit more clean and make a function about it. So I also want to make for speed one, so you can do that. So, but for that I also need to order a little bit the whole script thing. So let's see. So we need to make a function. So since we're gonna make this a function, this whole future, since this one thing was called the one future was called attack, we can just name it like attack, and then we have this. Let's see. So, voila. We can make this local so that it only exists in its function. So what we can assume is that the logic works the same for each future. So if we search speed, we have to do the same thing over again. Lucky I already knew the values because I found them before. So I have like a beautiful transcript. So here we have speed. I always do the same thing, basically. It's always the same. So here we go. But just imagine that you found the value already. Okay, so it's worked as well. And I do the same thing. I'm just gonna remove this. Oops. Save. So I do minus C. Make a copy. And then I do pointer search. Okay, remove this. You can always test manually just so that you for sure, you know. Then it was plus 10. Hex. And here we go again. So the fact that the method is always the same means that we can kind of create a function for it as well, so that we don't have to write everything like over and over again. So I just need to kind of think on how we're going to do that. Okay, so first thing first. So we know that we find a static value. We found a static value. We do minus C, get us to the address, and then from minus C, all we have to do is do the pointer search. Then we get our results. We do plus 10 and set the flags to double. And then we do the small filtering so that we capture all the values that only have like one digit behind it behind the decimal point, and then we are good. We can change all the values. So now we just have to script it. I'm gonna make a small change to this because some things are just not really like needed. So we know that we only had one result after finding this value, so we can just do or like we only got one result, and I'm quite sure like if you're not sure if you get only one result, then you just use the previous method with the get results count. So let's see. So instead of like making this separate, we can just do directly minus no 0xc, and we can remove this. In fact, we can actually put the search in a different function because it's the same anyway. So we can make a new function here. So function, and we can call it like filter, and then like pointer, and then again, like yeah, and we can just do we can just take this and put here. Then we can remove this. Let me clean it a little bit. Just want to close this function. So yes, so what's gonna happen? Now what we can do is okay. So it searches the value of the attack. We get results stored in the table, so we can clear the results. Then we need to call our function filter pointer. So we put filter pointer, which will search the result, one address minus 0c. So we have to work a little bit here. We can first work on this function here. So what does it has to do after? Then it has to capture the results. We don't always know how many results it has. Like sometimes it's 300, other times it's like 100. Now in this case, even in this case, it's 467. So we can just use the count equals get results count. So then it doesn't matter. We get results count will just basically get the amount of results, get the amount of subtables of the result list. So yeah, basically it will capture this value. Then I'm here we keep it local count, local results equals get results. Okay. Now what we can do is so yes for I comma v comma yeah for I comma v and compares results do. So yeah, results only will exist in this function, except there's this one thing. I'm just gonna change this, like I'm gonna change those names to result, like because it could add possible confusion, which I would not like to have. So now everything's called result. Like so, yeah, for IV input. So we need to do the address v dot address equals v dot address plus 0x10, and the flags v dot flags equals g dot type double. Okay, that should be it. And so now any function, like if there's no stats or speed or defense, we can always call this function here for do a filter. So now we already get to the double values. So now what we have to do, we have to load the results. Good, load results. Which is called results. Okay. Now the last part of the filtering, if it would be required, yes, it will be required, is making sure that we don't get negative values or like other pointers. We need to make sure that we don't edit other pointers along the way, you know. So because if you look here where we did offset, we are now, you have like pointers in between, so we need to filter them out. We need to filter those out, otherwise our game will crash. So what we can do is load the results. Let's first execute this part and see if everything is working fine. So let's see this. Can actually filter pointer. Okay, this part we could actually, let's just make sure it's like ignored. Voila. Let's like execute it. We can remove all this here. Let's get it again. Oh, oops. Yeah, this was supposed to be dwarfed. Oh no. One moment. Okay, so it's one. So yeah, very strange. First need to see what's happening. So search number, result one. What exactly happens? Let's just remove all this. Get result, clear result. So it should search result one address minus C. That worked. Hmm. Okay. Ah, I think I see it. Hold on. Okay, never mind. I was executing the wrong script, then saw it. So here we go. Okay, I forgot to call the function. So we call the function. So attack. Okay, perfect. It's working great. So we already have our double values. Nice. Now we just need to add the filtering method. This is a script that I have from the gameguardian forum. So it will basically search, like basic or refine the current values in the result list. Then it will add some math on it, and then we calculate the length, the string length from the point of the value, like the decimal point, to every number that's behind it. So we can just copy it. I'm not a math expert, to be honest, but I will leave a link below where I had support because I had help on the Game Guardian forum for make this. I believe it was from Monkey Sun. So we can basically copy this part of code. As long you kind of know what it does, it's fine. But I don't know it like straight from the head. So, but I get the idea because I used it a lot for my own personal interests. So yeah, we correct that after. So we create a table. We can call first table. Then let me see. So first we need to give the a result name. So we can just call it, let's see. We don't ever need yeah, we need it. So we can give it a new name. So A equals gv get results, and then yeah, then we can just we can use. I am, to be honest, not sure if count will stay the same as the previous one or if it will now update. I have doubts about that one now, but we can test it out later on. So A equals get results equals count. So then for K, make that local as well. Okay, the imperative. First. So now every value we desire, which is smaller than smaller or equal to one, um, so one digit behind the zero, will be added in first table. And then what we do is here we go the loop, load results first table. But first we need to have the refine. So it's something like this. I'm gonna refine number. Because otherwise it will count the zero as well, and we don't want the zero value. So 1, 2, let's say like 10,000. Doesn't necessarily matter as long that it's only one digit, and then type double. Yeah, now I do like to print A. I do like to print it to see what this get results are gonna be about. So should be fine. Let's try to execute again. Yeah, of course I've okay, my fault there. So yeah, the filtering went right. Just the printing went a little bit wrong. I want to because I'm not sure if I printed everything exactly. So I just can do like this, add list items. If I know that if it is the same amount, then it should not be a problem. Oops. If it gives him the safe list also 113, then it should be fine. Right. Caps. Funny. Okay, there was one added, I believe, but kind of odd. So I have here 114, and here I have 113. So I really believe that very strange. So for now, I will just put 1000. I will think about this later, what it all is about. I know it should just be fine. So okay, so the first part went through. Um, so I do change my mind. We make a second function, filter function, and we call it filter value. And now we can here as well, use local count because to be honest, I don't like the way I made that filter pointer function. It's a lot of stuff in it that actually I don't think should be in one function. Get results, count. And then what's basically come down to is we just copy this, but we just write it with the filter table. And we place it here. Voila. So if everything is looking good, done. So there. It basically looks okay. Looks good. Unfortunately, we had to like reference another table again, but it should work just fine. As long the desired values are in the result list. So now let's see. Let's work back on our function a little bit. So after this function is complete, we call this function in case we need to filter. So that should be just fine. Okay. So this we can remove. It was ignored all this time, but we can just remove it because I wanted it to keep it as a backup. So we put the filter value function, we call it after, and then okay, so we have these results. This is what we get. So yeah, then we can just well, if you like to, you can store it under a name or something, and we can edit it like oh yeah, first we get it. So what we call it, you can literally call it attack equals get results. And here as well, we have to use local count. Get results count. And then local results doesn't get results. Voila. Get it. Yeah, so here we can just call it attack. And this doesn't necessarily need to be local. There's only going to be one variable that we will call attack. So call attack, and then do, and then v dot value equals, for example, 9999. P dot name equals attack. As they spell it here, you can just call it how they referenced it. That was a pointer. So name that tag, so we can just call it tag. Then and then just like add list items. I believe we had to put the set values as well, but let's just test it out first. So our script should be working. Mm, let's test it out. And always delete. List items. Oh, yeah, you cannot just add random list item. So we have to put attack. The list item attack. Let's just include again. Okay, so the names is there. It's called attack. All those values are called attack. It just then edit. So because we need to set the values, we're gonna set values attack. There we go. Let's try one more time. Voila. So now all the values are changed to attack. When we revert them, you can see they will just go back to normal. Voila. So yeah, that's kind of how we got our first function. So nice thing now is that we can create the other functions very easy. We already have the base, which is literally like the first filter, which do the offset calculations like minus C, then plus 10, which then gets us to the double value. And then the second filter, which like basically is a more extreme form of refining every value between 1 to 1000. And then we put that in a we reference that table by name A, then we do some iteration over A. Actually, this can just need to be K and T. But in this case, I don't want to touch this because Monkey San he pretty much made this, and I'm gonna put the link in the description below. So I, out of respect, I just won't touch it. It's also not needed. So yeah, this is the biggest part of the filtering, and then it loads the results in the table. Sorry, in the result list, and then it jumps back to attack, play continues, capture the count, and then attack. We iterate over it, and then we edit all the values to 999, but you can edit to whatever you want to. We name all the values on those addresses. We name it attack. Then we set the values so that 9999 is set, and we add them to the list. So now I want to do for speed, and it's pretty much the same thing. So so we don't need this really. Like we can just close this. It's not needed. So we can create our other functions. So it's always the same thing. So function, what was it? Speed. Like look, like if I search it, what was I searching it? One value, and it's the same thing I showed before. Go to address, pointer search, because it's minus C, just have to delete this. Yeah, and then you save plus 10, and then the filtering on it, double, you filter on the string formatting. Remember, string the formatting is the same thing as this function here. It's basically the same thing. And if we edit them, okay, all So I want to make a function as well for potential level. So basically the same thing, but then for potential level. So let's check it out. So yeah, our base we already have, the filters we already have. So let me check what was the value again. I think it was minus 13. No, wait. Uh, I believe it was this. Okay, here we go. So yeah, here get potential level it's called. Again, offset C. Get like only 6 results. Save and then plus 10. Double 2 1. So you know we need those. Anything between 1 and whatever, like 1 and all the way up, you know. So here you see we hacked the points, potential level. We hacked them, like modified them of the others as well, of all of them. So we can script this now as well. And it's the same thing again. So we can call the function get level uh, moment. Yeah, function it is. Like use a name that's like easy for you to remember or like not struggle with it. So yeah, search number. What was the value? Right. Type word. You can see that it is way faster than doing the group search, you know. So can make this all local. Oh, one thing. No, we cannot make it local. We cannot make it local because it has to exist here because we use it in the other function. So let's not make it local. Hold on. So get results. I'm not that like experienced in the scripting, but like getting a little bit better, like in the efficiency. A little bit, too much. But so yeah, so it's basically the same thing. So just a different value. I mean, if you really want to, you can make this more like way more optimized because at the end of the day, we are still writing like basically like similar things, but you can still like optimize them. So then local count equals sales count. I don't want to like be nice and copy paste everything because it will be basically the same thing. But I prefer to write things out. So instead of attack, we call it yeah, what we call it like get pot get potential level like reserve count. Voila. I like to write out the names at full. Uh, it makes it easier for me. Do the value. No. Of course, you edit to what you want. Video name equals exactly status points, then end. And then it's a level list items. You don't need to add them all the time, you know. It's not needed, just for the sake of the video. So, mm, should be fine. Let's test it out. So yeah, we have to call the function. Get level. We can ignore this function for a while just to see how everything is working all great. There we go. Oh, I'm executing the wrong script. My bad. Hmm. Okay. Maybe I'm searching the wrong value. Or what? One moment there. Okay, that's a different value. How I see it here. It's a very different value. I think that's this may be defense or something. Yeah, okay, that was for defense. My bad. Let me see. It was different. 1, 2, 3, 6. And I assumed I copied correctly. That's good. Yeah, this was a value. Yeah, no, it should be great. But as you see, it was working as well. Funny enough, it just then took the right one. There we go. Perfect. Voila, here we have a status point. Everything seems to work great. Voila, they are hacked. They're also modified. So yeah, so basically, it's like that. You know, it's way faster than the group search. In this case, we use two. We basically scripted. We made a quick script. I know it took a bit some time. I'm not that great. I'm not the good scripter, to be fair, but I tried for the tutorial purposes a bit. So yes, look, we can even. What's always safe to do is always before you start a function use clear results just to make sure, you know. So before I start searching, everything is clear. Results. Voila. It's always the most safest. And then you also want to put correct memory regions. Like so we set uh, range. So this. Then so that you uh, no, I don't want to make a mistake. I really believe it was one moment. Yeah, within region. See outlook. So now it will only search in region C A. So C log. It will only search here. And for the other function, the same thing. Dot region C log. So in each function and both function where we have to search a value, we put it the range. So if we just happen to like disable all of those, it will show, it will search for the CA range. Voila, there we go. So yes, man. I still believe like pointer searches are still the fastest ways for a search for a value. But everybody has choice, of course. But like now we, how to say, I'm quite sure we can make this even way shorter if we like to. Because I think basically beside the naming, I guess the whole editing of the value can also be put in a separate function, so that we don't need to write that several times again. But now, from my head, this is more or less what's first pushing through the mind. So yeah, everything is working fine. So yeah, if you, I always advise to use pointer searches. It's way quicker because you're just searching one value. You can also use hack search, but like group search, like it's still a form of a group search in some way. So it expects that, I mean, it expects that all the bytes are on the appropriate address and the appropriate distance. And if that's not the case, the search will fail. So me personally, I prefer doing pointer searches. I always prefer that. But everybody has choice. But either way, guys, have a nice day. Just keep in mind this was the first tutorial. I know we went a little bit more into the scripting. I mean, it wasn't deep. It was just along the way, basically. But in the second tutorial, I do gonna have to explain a bit more about like the metadata, or like the executable in general, how we can start doing pointer searches from there. But the main concept is the same. Like always do like pointer searches, and you get your values quicker than using group searches. Have a nice day, guys, and thanks for watching.